In this video, we are going to do a couple of Monte Carlo simulations. We'll start with a simple form with profits based on revenue, variable cost, and fixed cost. We're going to do a small version of this so you can get an idea of what's going on with a Monte Carlo simulation. Then we'll do a more a more elaborate one, an extended one with cash flows and net present value. So let's start here. Let's say we have a situation where we have an expected revenue of $194,500. Variable cost is expected to be about $100,000 and fixed costs about $60,000. However, in this project, these numbers are averages, but they may vary. So we have the standard deviation. The revenue has a standard deviation of $15,000. Variable cost here has a standard deviation of $40,000. And the fixed cost standard deviation of 4,000. So the Monte Carlo simulation, there's many ways you can actually set this up in Excel, but we're going to use this approach using a few functions in Excel to see how we can make our life a little easier. So we want to do a simulation first of one potential outcome, one potential trial, one iteration. So what we do is we're going to create a potential scenario that takes in consideration the revenue that we expect, takes in consideration the standard deviation, and we will add that there's a random probability in which that may change. So the function we want to use is going to be the normal distribution inverse in order to get this simulation that we want. Once we have that function in place, we open the parentheses, and the first thing it wants is a probability. Since we don't have a set probability that we're going to use the rand function, which what it does is going to give you a random probability between 0 and 1 and in each simulation that it runs. So it's going to change that probability of certain scenario happening. Then the next thing it wants is the mean. That's going to be our expected. So we grab the revenue, the expected revenue, which is the mean in this case, the average. And then it wants the standard deviation. So we're going to use the standard deviation of revenue. So we close the parentheses there. And it's going to start giving us some random possibility of revenue based on the standard deviation and the average. Then we're going to do the same thing for variable cost and the same thing for fixed cost. We can just drag it down in this case. Now notice that every time we interact with Excel, Excel is kind of recalculating, and that's fine. You don't want to, there's a way to stop it, but we don't want to stop it. It will make more sense at the end because you want to see a variety of simulations. So right now, every time we interact with Excel, it's going to do a recalculate a simulation with a different probability, and that's fine. Don't worry about that. That's normal. So you see how these are going to change. Now profit, we know it's going to be revenue minus the variable cost minus the fixed cost. And in this case, in this simulation, it gives you negative profit, which is a possibility. Now, if we go here on formulas, you see what it says calculate now? You can click on that, and every time you click on it, it'll give you a new scenario. Now notice in this case is giving us now a positive profit. And all it's doing is giving you a different potential scenario out of the thousands or millions of potential scenarios that could happen based on this information. Okay, another way to do it, if you notice, it says calculate now F9. So instead of going there and clicking on it, if I just go ahead and press F9, it'll go ahead and take a moment to recalculate another scenario. Okay, so this is one simulation, but we are interested in the different profits that we may achieve based on these parameters. what will be the average profit? What will be the standard deviation of that profit? You see, we won't calculate it directly from here. We want to then do a lot of different potential scenarios, and then calculating the mean, the standard deviation of profit, the minimum, the maximum. We'll talk about skewness and kurtosis in a moment. And then we want to know the risk of loss. What's the probability of getting a negative profit? As you noticed earlier, some are negative and some are positive depending on the product. So depending on the scenario in the simulation. So let's say that we're going to set up a series of trials so we can get a bunch of different outcomes. Instead of doing one by one here, we can do a lot of them. All right, so let's say we're going to do 1,000. 1,000 is a typical number used in a Monte Carlo simulation, but the more you do, the better. So I could just put a 1 there and start dragging down 2, 3, 4, 1,000. But let's go ahead and use a tool that we have here called, fill. So it says fill. You can go to series. Now I have to put a 1 in there first and be in that cell. So I'm going to go here to columns because I want it to go down. All right. And the 1 is already there. And we say that we want it to be 1,000. Okay. And the rest you'll leave it the way it is. And what it did there, it went ahead and auto filled all the way to 1,000. All right. Now, this first one, we're just going to equal it to this one here so it knows what it's working with. That this is the one that is going to be changing. So right now, whatever comes here is going to show up here. So I have F9 that recalculates another simulation, it will change. Now, what we want to do is for each one of these going all the way down to 1,000 to give us a different scenario using this as the basis. Now, this is where we're going to deal with a table that we build in Excel to do that for us. Now, notice I highlight both items. I highlighted both items. Then I'm going to hit Control. I'm in a PC, so Control Shift. It may be Command in an Apple computer, but I'm in a PC, so Control Shift and then down arrow, and it's going to highlight all the way down to the 1,000. Okay. Now I can continue working down there, but I want you to see what's going on here. Now, if we go to the what if, it says data table. We're going to use this. What if analysis? We go to data. What if analysis? Data table. Now we're going to ignore the row input cell because we're dealing with columns. Now this probably doesn't make sense, but this is how it works. Excel needs a place to do the work and then populate the table that we're trying to build here. So all you have to do is, once you highlighted the appropriate ones and you have this data already in there, pick any blank cell. But you want a blank cell that is not going to interfere with anything below it or above it. So I'm just going to go here on the J8. And it's just a place for Excel to do the work it has to do, and then it comes back here and populates it. When I hit OK, it's going to take a moment, but now that's what it did. Let's put some $signs in there. I'm not going to go all the way down, but just enough so it doesn't look too bad. And what you have here now, it's 1,000 different simulations of profit based on these parameters. Okay. Now that we have that, we have 1,000 potential outcomes. So we can start looking, okay, so what will be my average profit? Now, like I said, every time we interact with Excel, you're going to see these updating. That's fine. We're just going to go ahead and finish this other table here. And then we start talking about what does it mean and how do we use this? All right. So for mean, I'm going to use all these potential outcomes, random simulations. So I can use the average function. If I spell it right. And well, I'm going to use H8. And I know I got 1,000 entries so that I can just write H1007. Now, the reason it appears that I'm not going 1,000 down is because we're counting H8 as one of them. If you notice, we start here, and then when I go all the way down, it covers all the way down to that 1,000 entry. All right, so now what I'm going to do is I'm going to put the dollar signs by pressing F4 so I can lock this in place. All right, so once it takes the calculation, it's giving me the average of all these 1,000 entries. Now, what I'm going to do to make my life a little easier, I locked them in place. So I'm just going to go ahead and drag that formula down, and then I'm just going to adjust the formula as I go. Right now, it's giving me the same number because it's doing the average for all of them. But each one of these have their own function. For example, now I can just go in there and change the word average for standard deviation. Now we're going to use standard deviation S as in sample. We prefer that in finance when we have a sample instead of the entire population, which in this case will be infinite. And there's a little more conservative approach. So now it's giving me the standard deviation there. For minimum, same thing. I'm just going to go, since I already have the H8 to H1007, I'm going to go ahead and change average to the minimum function. Just hit enter. Let's go ahead and expand that. And what it's telling me that the lowest number in these 1,000 entries was whatever shows up there. Now we can do the same for max. I did it up here in the function bar because you can do it there as well. Now, before I do skewness and kurtosis, let me go ahead and talk about a histogram. So I'm going to go here, Control Shift down. So it goes all the way down to those. So I have highlighted all the profit entries. And what I'm going to do is I'm going to go Insert, go to here, Charts, and I go to All Charts, and I'm going to select Histogram. Okay, so this gives me a histogram, which is a probability distribution. And notice how it has that bell curve shape for like a normal distribution. Now, the reason I did that is because skewness, it's something that we like. We're not going to get into skewness right now, but it's a good number to have when you're doing some other statistics on your project. But know that Excel has that for you. So I can just put their skew, and that's one of the functions. And what skewness tells us, and we should use that better. Let's format these two as a number. 2 decimal places like that. Okay. Well, skewness is giving us a number that talks about if this bell curve is a little skewed left or right. And let me tell you what I mean. I'm going to hit F9 to recalculate. Notice how the shape changes, but let me see if we can get one with a higher skewness that we can really appreciate visually. Now, in this last change, notice how it moved to the right a little bit. The bell curve seems like it's shifted to the right, and that's when you get a negative skewness. So it's skewed in that direction. However, ironically, it's called skewed left. That's for another class why that happens. Notice here that it also changed the shape of the peak here, and it moved a little bit as well. And your skewness over here changed. Now, this one that has a sharper peak than the previous one, that's where kurtosis comes in play. So let's change that to kurtosis. We have kurt as the function. And this number tells us how pronounced that peak is. Notice this one now doesn't have much of a peak, so you got like a negative kurtosis. So I'm going to hit F9, so we can get another peak. Now this one was a little more pronounced, so it gives us a larger number. Let's get another one, F9 again. Now we have a positive number, and there was a slight change, so it's very unnoticeable, but kurtosis tells us that. And that's good for other, now Now notice how Kurtosis is much higher now, and we have a much pronounced peak. Well, okay, so risk of loss, what we're going to do here is we want to know out of the 1,000 profit scenarios, how many of those were negative, and then express it as a percentage. So what we're going to do is we're going to change this to count if, and then once we select count if, is asking for the range. Now the range, we already have it from H8 to H1007, but then it wants to know the criteria. So we want to know the ones that are less than 0. Now Excel needs the quotation marks to understand that expression. And all it's doing is from the 1,000 that we have, how many are less than 0? And then in order to get us a percentage, because we're doing a risk, like a probability thing, we just divide it by the 1,000 because we have 1,000 entries. Hit enter, and I'll change it to percentage as soon as it calculates. And there we have it. So under this simulation of 1,000, there is a 22.7% chance of having a negative net income or negative profit for losses. And all it's doing is checking all the negatives here divided by 1,000. So 227 of these are negative. But that may change every time we recalculate with a new set of simulations. Now it went down a little bit. But typically it hovers up and down a certain value. In this case, it seems to be between the 20 and the 22 or 20 and 23. So you can confidently say that, well, we are in that range of potential loss of this project. And you will notice that mean standard deviation will also kind of hover around the same numbers, but it gives you minimum, maximum, it gives you a lot of information for future calculations. Okay, so we will stop this video here. And the next video, we will do the more elaborate version with cash flows and PV and the Monte Carlo simulation. And see you on the next video.